Goddess Saraswati, burn the darkness of evil with glow of knowledge, and may your life be filled with internal light of knowledge. So, wishing you success, peace, and progress on this day. Happy Saraswati Puja again. Come back. Today I will see some example of correspondence theorem, because this theorem is more important for any competitive exam, not only CSIR net. Let's see the question. This question had come December 2015 CSIR net exam. The question is, let capital A denote the quotient ring QX modulo XRQ, ideal generated by XRQ. Then option 1, there are exactly 3 distinct, here notice the proper ideal in A. Option 2 indicate there is only one prime ideal in A. And option 3 indicate A is an integral domain. And option 4, let Fg in Qx such that F bar times G bar equal to 0, bar means here the quotient ring in the set A. Here F bar G bar denote the image of F and G respectively in the set A. Then we have to prove F0 times G0 equal to 0. Here the set is look like A is denoted as QX mod XR ideal generated by XRQ. Correspondence theorem here apply from QX to QX mod ideal generated by XRQ. And in the ring QX, the kernel of F equal to ideal generated by XRQ, which is denoted as I, and J be the ideal of QX containing the kernel of F. So, in the ring QX mod ideal generated by XRQ, the ideal is look like R mod J, where or the from ideal of R mod J or the from I mod J, where I is the ideal which is containing the ideal J in QX. Are you getting the from? Okay. Here the ideal of Q mod ideal generated by XRQ, R of the from J mod ideal generated by XRQ, such that J is the ideal containing ideal generated by XRQ. Are you getting the concept? Okay. Among this ideal, only QX be improper, because in the question has indicate there exists exactly 3 distinct proper ideal in the set A. And ideal look like in the ring QX modulo XRQ would be ideal generated by X modulo ideal generated by XRQ, ideal generated by X square modulo ideal generated by XRQ, and ideal generated by XRQ modulo ideal generated by XRQ. Are you getting? There are 3 distinct ideal in the ring QX modulo XRQ. That means option 1 is a right option. There are exactly 3 distinct proper ideal in the ring A. And second option, there is only one prime ideal in A. And since QX mod ideal generated by XRQ has only 3 distinct proper ideal from this concept, therefore by third isomorphism theorem, just recall the third isomorphism theorem for rings. Let R be a ring and I and J be the ideals of the ring R with the condition I contains J. Then obviously Z mod I is an ideal of the ring R mod I. Then by third ring isomorphism theorem, we can tell R mod I modulo J mod I is isomorphic to R mod J. Are you getting the idea? Therefore, by third ring isomorphism theorem, in the ring Qx mod ideal generated by XR cube, Qx modulo ideal generated by XR cube modulo X modulo ideal generated by XR cube, by third ring isomorphism theorem, this would be isomorphic to Qx mod ideal generated by X. And we all of us know this ring means Qx mod ideal generated by X is always isomorphic to Q. Because I had discussed this ring Qx mod ideal generated by X, which is isomorphic to Q, elaborately in my earlier video. So, are you getting why I have told you why my previous video is more important to know the ring theory proper way? If you don't see my earlier video, at first I will highly recommend you, please see my earlier video. Now say, by this property, since Q is a field, so we can tell obviously this ideal be maximal ideal. Okay? That means this ideal X mod ideal generated by XR cube is maximal ideal in the ring Qx mod ideal generated by XR cube. Obviously, since maximal ideal and since Qx be commutative ring with unity, therefore obviously this ideal also prime ideal in this ring also. Other method is, if you don't want to use the definition of third ring isomorphism theorem, then just use the definition of prime ideal in the ring A. Since here the ring is Qx mod XR cube, then actual operation would be look like, if we consider the ideal I2 equal to x square plus ideal generated by XR cube, this is not prime ideal, because if we consider two arbitrary elements from the quotient ring Qx modulo XR cube, here the element is look like x plus ideal generated by XR cube and x plus ideal generated by XR cube. Then their product is equal to x square plus ideal generated by XR cube. And notice here product is belongs to I2, but neither the element belongs to I2, because x modulo XR cube not belongs to I2. Similarly, this is same element. Similarly, if we consider I3, which is equal to ideal generated by XR cube in the quotient ring Qx modulo ideal generated by XR cube, here if we pick two elements from this quotient ring Qx modulo ideal generated by XR cube, one x plus ideal generated by XR cube and other x square plus ideal generated by XR cube. Notice their product would be XR cube plus ideal generated by XR cube, which is actually same as ideal generated by XR cube. That means obviously here product of these two element of this ring belongs to I3, but neither this element belongs to I3 nor this element belongs to I3. X plus ideal generated by XR cube not belongs to I3. Also, x square plus ideal generated by XR cube not belongs to I3. So obviously ideal generated by XR cube not be prime ideal. Are you getting? Well, option 3 indicate A is an integral domain. This is always easy option. In the ring QX modulo ideal generated by XR cube, I3 be the 0 element. And if we consider this product, consider this is A and this is B. Notice their product be 0, but neither A equal to 0 nor B equal to 0. That means this ring contains 0 divisor. Are you getting the idea? That means the ring A is not B integral domain. Now let's see the option 4. Option 4 indicate let Fg in Qx such that their product means F bar times 0 bar equal G bar equal to 0 bar in the set A. Here obviously F bar and G bar denote the image of F and G respectively in the set A. Then prove that F0 times G0 equal to 0. For this, consider two polynomial fx equal to a0 plus a1x up to anx to the power n and gx equal to b0 plus b1x up to bkx to the power k. Okay? And in the question has given f bar times g bar equal to 0 bar. And in the set, this condition has satisfied in the set capital A. And obviously all of us know 0 bar in the set capital A means this is equal to I, and in the set capital A, F bar is look like F plus I and G bar is look like G plus I. If we put the value, then this would be F dot G plus I equal to I. And from this line, we can tell easily F dot G belongs to capital I. I means, since here the ring is Qx modulo XR cube, so by the definition of ideal, this is F dot G equal to XR cube times Qx. Okay? And from this relation, if we put the value fx and gx, then this would be a0 times b0 equal to 0. Is a0 means just f0 and b0 means g0. So, therefore, f0 times g0 equal to 0. Therefore, our proof has done. Means option 4 also right option. Are you getting? Oh well. I will stop here because today is Saraswati Puja. Wish you again joyful Saraswati Puja. See you soon. Stay safe and stay positive always. And don't forget to do subscribe my channel for more videos. Thank you so much.